Today we're going to look at component form and direction angles, how to find the direction angles. Remember, a vector has magnitude and direction. So we've already found how to find the magnitude of a vector. If v is already in component form, a and b, then the magnitude of v was equal to the square root of a squared plus b squared. To find the direction angle, what you do is there's a formula for it, and you can think about it in terms of this. If I had vector AB, vector V right here, this would be A, this would be B. How would we find this angle right in here? Well, the tangent is opposite over adjacent, or B over A, right? So to find that angle, you'd use the inverse tangent. So for the direction angle, once it's in component form, what you do is you would find theta is the inverse tangent of B over A. And that's what we would do it. That's how you would do it. You'd put that in your calculator and you'd find out what that is. Okay? The problem is sometimes, if you remember, inverse tangent is only defined from negative 90 to 90. What happens if my vector is over here? So what I did is I came up with a neat little formula for this. Whatever your calculator gives you, if it gives you the angle in the first quadrant, if it gives you a positive angle for that, so theta is greater than 0, it'll give you this angle. If it's in the second quadrant, what you're going to do is you're going to take whatever that calculator gives you and you're going to add pi to it, or 180 degrees, whichever type of thing you're in. If you're in this one, well, remember that tangent has a period of pi, so whatever the tangent up here is, that's what the tangent down here is. So you're going to take whatever calculator gave you and you're going to add pi, or 180 degrees. If it's here, it's giving you a negative angle. Well, we want to have it be positive, so we're just going to add 2 pi to it, or 360 degrees. Okay? So if I gave you that we had a vector v that had in component form was, I don't know, let's say 3, 5, and I wanted to find what's its magnitude and direction. Okay, that's what I want to find. Now the magnitude of v is just the square root of 3 squared plus 5 squared, which is the square root of 9 plus 25, 34. To find the angle, what I do is I go, well, I'm going to go the inverse tangent of b over a. So 5 over 3. I go ahead and I get my calculator. I don't know what that was from, but I get my calculator and I go ahead and I do that. So I'm going to go second tangent. Again, let's make sure I'm in degrees. You want to make sure your calculator's in that mode first. Inverse tangent of 5 divided by 3. And that gives me 59.036. So that equals about 59.036, right? Well, I go back to look at this right here. This is in the first quadrant, positive, positive. If it's in the first quadrant, I'm going to use whatever theta that I got. So my direction angle, here's the magnitude. This, my direction angle then, is equal to 59.036 degrees. And that's your answer. There's my magnitude, there's the direction. Okay? Now, sometimes what if it was a different type thing? Let's look at another example. Let's say that v was equal to negative 4, 3. Well, I don't like 3 because that gives it the magnitude too easy. Let's say negative 4, 2. Okay, negative 4, 2. So the magnitude of it would be the square root of that squared, which is 16, plus 2 squared, which is 4. So that's the square root of 20. The direction angle is the inverse tangent of b over a, 2 over negative 4. You can reduce that if you want, but we're just going to use a calculator. I'm going to go second tangent of 2 divided by negative 4. And I get negative 26.565. So that equals about negative 26.565. Now we look at where this is. Negative 4, positive 2. We're in the second quadrant, aren't we? If we go back to our little key up here, if you're in the second quadrant, you take whatever the calculator gives you, and we're in the second quadrant, we add 180 to it. So what I'm going to do is take this answer, and I'm just going to add 180. So my direction angle is 153.435. Direction angle equals 153.435 degrees. And you think about that, if you were negative 4, 2, that seems reasonable that this angle from the positive x angle is 153 degrees. Seems highly likely. Okay, that's how you find a direction angle. All right, it's that little formula right there. You just have to, whatever, I don't really need this in here, whatever calc theta the calculator gives you, you're going to use it if it's in the first quadrant, like this example was. That's my direction angle. If it's in the second quadrant, I'm going to add 180. If it's in the third quadrant, I'm just going to add 180 to it. And if it's in the fourth quadrant, I'm going to add 360. All right, and that gives you what the direction angle is. Okay. Now, sometimes what they do is they want you to find component form, and what they do is give you a picture of, say, that has a length of 10, and this angle is 203 degrees. And I want to find the component form of that vector. Okay? So what I have to do then is I have to come up with a formula for it. And here's the formula for finding component. If v has a direction angle of theta, so if a vector has direction angle of theta, then the following is true. The component form of v is the magnitude of v times the cosine of theta, and the magnitude of v times the sine of theta. And that's our formula that we use when you're trying to find component form, when they just give you the magnitude and the direction. It's kind of like going backwards. Once they give us the magnitude, how do we find what a and b are for the component form? Okay, this is a way of doing that. So let's look at an example. Let's say that this example right here. I know then that in component form of v, it would be 10 times the cosine of 203, 10 times the sine of 203 degrees. That's the component form. You just take your calculator and you just do each one of those. So if I were to do that, here, I'll move it up a little bit. I'm going to go 10 cosine of 203, and that's negative 9.205. And then I do 10 sine of 203, and I get negative 3.907. Okay? And so really, if you think about that, if I were to draw that out, -9 went out here, -9.205, and down -3.907. That looks like that probably would be an angle, could be 203 degrees. And if you were to take and find the magnitude of that, what you'd find out is that that does equal 10. This squared plus this squared, the square root of it. Okay? All right, so one more example is let's say I gave you that we had V was equal to 5 times the cosine of 225i plus sine of 2j. And what we want to do is find the magnitude and direction of that. Okay? Well, we already know these values from our unit circle. Okay? But what I'm going to do is I'm going to actually multiply this out so that it's in ij form. V is going to equal 5 cosine of 225i plus 5 sine 225j. The magnitude then is this is A, this is B. So the magnitude of V is going to be 5 square root of 5 cosine of 225 squared plus 5 sine 225 squared. So we take the calculator and we just work that out. So square root, parenthesis 5 cosine of 225 squared plus 5 sine. I guess I don't need that parenthesis in there. Oh yeah, I guess I do. 5 sine 225 squared. Better go back here and check. I don't think I put enough parentheses in this. Yeah, I need another parenthesis right in here. There, because now I want to square that whole thing. And I hit enter. Oops, I screwed up still. What did I have? Oh, I didn't get my number in there. 225. Squared. Okay, I don't know what's going on. I got to start again. This happens sometimes. Parenthesis 5 cosine of 225. That whole thing squared plus parenthesis 5 sine of 225 squared. And we get 5. If I were to do the direction angle, it'd be the inverse tangent of this over this. So theta is going to be the inverse tangent of 5 sine of 225 over 5 sine of 225. So if I were to put that in my calculator, inverse tangent, inverse tangent, I'm having all kinds of problems today. I want a fraction, 5 cosine of 5 sine sine 225 over 5 cosine 225. And I get 45 degrees. Okay? But if you went back here and looked at this, we know the cosine of 225 is negative, and the sine of 225 is negative. So these two numbers are going to be negative. That means this is in the third quadrant. What I would do would be add 180 to that, and I get that theta equals 225 degrees. Now look at the shortcut. Look what we ended up getting. This was the magnitude when it was written like this, and this was the direction angle. So we don't have to do all of this stuff. I just wanted to show you that that's how you would do it if you wanted to work it all the way out. But if a vector is written as the magnitude of v times the cosine of theta I plus the sine of theta j, there's a formula. So if it's written like this magnitude is this number out here is the magnitude of it. This is the direction angle. And so it's a lot easier way of doing it. All right, that's what your assignment's on today.